All right, geometry students of Tennessee, my name is Lee Pierce, and this is for my class at Sequoia High School in Madisonville, and we're doing some geometry EOC practice. Now, this practice was actually created by the folks that make the EOC, but that's not to say that every question that we do today is going to be just like one on the EOC. They're all going to be a little different, and we don't know what's on the EOC. We don't know from year to year. We get some item releases, but that's about it. So, that said, this is Geometry 1 through 12 or 1 through 11 area EOC practice. So, when you grab your sheet of paper, which you must turn in when completing this, make sure it says Geometry 1 through 12 area EOC practice, all right? And have the date and your name on there. That never hurts also. Okay, so let's go ahead and get started. Now, I will say every single problem on here seems to focus on the fact that there are different units in the length and the width or somewhere in the problem. So let's just deal with that. I'm not sure that that's a big thing on the EOC, these varying units or the having to convert units, but we're going to do that and we'll remind you how to do that, all right? So the first one, a triangular piece of wood has base length of 4 feet and a height of 9 inches. See the different units? We got feet and inches. Now we can't figure out the area of a piece of wood when the length is in feet and the height is in inches. So what we've got to do is convert one or the other or both, either before or after. I know that's a lot of choices. There's no necessarily best way to do it. But what we're looking at here is we've got this triangular piece of wood and the length is 4 feet. I'm going to go ahead and call that 48 inches, okay? I'm just going to do a quick in my head conversion and call my 4 feet 48 inches. I'm going to call my height 9 inches. I know it doesn't really matter. Length and height can be considered base and height. It doesn't really matter that much as long as the units are equal. So we've got 1/2 base times height. That is the area of a triangle. So we can just do our 48 times 9 very quickly, and we come up with 216. So that is one of our answers because that is in square inches. When you multiply inches by inches, you get square inches. Now, we can go one of two directions to find our other answer because there is another answer. We can remember that in a square foot is 12 inches, right? 12 inches is 1 square foot. 12 inches on a side. So 12 by 12. A square foot is 12 by 12. So a square foot is actually 144 square inches, all right? So we can divide our 216 by 144. Remember, if we're going from smaller units to larger units, we're going to have fewer of them, so we divide. If we're going from larger units like square feet to smaller units like square inches, we're going to have a lot more of them, so we multiply. So let's do that, and we end up with 1.5 square feet. So the answer to this one ends up being 1.5 square feet and 216 square inches, C and E. But there is another way to think about this, and that is before you convert this, you can do this and do your inches with 48 times 9, and then you can erase that and convert the 9 to feet. So we've got one height of 4 feet, and this would be 0.75 feet. Because 9 inches is 9 out of 12, which is the same as 3 out of 4, which is 0.75 feet. So then you have them in feet. 1/2 that times that gives us the same thing, 1.5 square feet. All right? Let's move on. We're going to have to deal with this in almost every problem here. This one's probably the easiest one of the whole thing. It just asks to calculate the perimeter. What is perimeter? Let me ask the class. Eli? Randy? Haley? Nobody wants to answer today. So I'm just going to calculate the perimeter of the figure. But we can't actually calculate it. We can, but they don't ask us to. They just say which units make the most sense. Feet, inches, yards, or centimeters. Obviously, we don't have any yards or centimeters, so we can cross off R and S. Those are the ridiculous answers. So feet and inches, we've got feet here, feet here, feet here, feet here, feet here, inches here. So would you rather convert all of these to inches or just that one value to feet? Obviously, you just convert that one value at the top to feet, and we get 0.5 feet because 6 inches is, well, we don't actually have to solve it, but 6 inches is 0.5 feet. And now everything's in feet, and we could add them up if we needed to, but we're going to go with feet because most of the measurements are given in feet. All right, moving on. Anita measures 3 pieces of yarn. Thank goodness we only have one answer this time. Three pieces of yarn and finds that their lengths to be 1.3 meters, 25 centimeters, and 0.75 meters. So we've got 2 meters, 1 centimeter. Let's convert the centimeters to meters. 25 centimeters, the conversion factor or the conversion ratio is 100 centimeters to the meter. So the centimeters cancel, and we divide 25 by 100, and we get 0.25 meters. So instead of 25 centimeters, we're going to call it 0.25 meters, and then we can just add them up. 0.25 plus 0.75 is 1, plus 1.3 is 2.3 meters. So A is the answer to that one. Again, those conversions are what you would put on your scratch paper. I told you number 2 that we just did, it wouldn't really require any scratch paper. It's just a thinker. But make sure you number your scratch paper and put your work down on it. All right, so we've got to actually, this is a 3-in-1. We've got to actually calculate 3 different values in this one. And we're doing volume. And I want to remind you really quick, on the EOC this year, you will be given a reference sheet. The reference sheet has a tremendous number of, well, I can't see it, tremendous number of formulas. So we've got area of parallelogram, trapezoid, and triangle. Unfortunately for volume, they only give you a right prism. Now a prism is any 3-dimensional figure with the same exact shape on each end. You know, it's not like a pyramid that goes to a point. It has a shape on each end, either the front and the back, or the left and the right, or the top and the bottom, depending on which way it's oriented. But it has that same shape at each end. So that is a prism. So the prism is area of the base, whatever that happens to be. It could be a circle. Well, actually, that would be a cylinder, but it's kind of the same concept. It could be a triangle. It could be a hexagon. It could be a rectangle, and that's what we're working with here. All right. So we're working with a rectangular prism, otherwise known as a box. And it has a length of 10 centimeters, a width of 0.5 meters. Again, we've got the different units, all right? So we want to find out the volume of the prism if it has the following heights. So 80 centimeters. So let's draw and label this thing, and we'll get an idea of what's going on here, all right? All right, so we've got a box here. A rectangular prism has a length of 10. We're going to give it the height of 80, and that's in centimeters, so we're going to convert everything else to centimeters. Half a meter is 50 centimeters. That's the width. And the length is 10 centimeters. So we multiply all of these things together. So length times width times height is area of a box or a rectangular prism. And we go 80 times 50 times 10, and we get 40,000. Now, 40,000 is the equivalent of 0.4 meters. Wait. 40,000 is the equivalent of 0.04 square meters. Now, that is a little bit confusing. When you think of a square meter, we think of a cube with a side length of a meter, or 100 centimeters. So 100 times 100 times 100 is 1,000,000. And so we actually divide what we got here by 1,000,000. And we get 0.04 square meters. That's a pretty tough problem. It's a lot of conversions going on here. All right. So, what do we do now? We've got 2 more to figure out. So we'll work these both the same. Fortunately, once we get it labeled, once we get it drawn and labeled, we can do it the same for both of these because they're in the same units. We've got 1.4 meters and 0.4 meters, so they're the same units, so we'll be able to do everything the same. Now we got to convert everything to meters. Fortunately, these two are in meters and our answers are in square meters, so we won't have to do that weird dividing by a million conversion. But let's forget about this one. We've already done this one. That is 0.4. Of course, that's the answer is going to be down here. 1.4 meters is the height, 1.4. We've got 0.5 meters here, and 10 centimeters divided by 100, and that is 0.1 meters. So we can just multiply these things together. This is great. 0.1 times 1.4 times 0.5 gives us 0.07, and we're never sure exactly, so we're gonna double check this answer. We're not just gonna use the process of elimination unless we're running out of time, okay? We're gonna work our answers out. So we're just gonna change our 1.4 to 0.4, and if you're really clever, just change it in your calculator to a 0.4, and we get our 0.02, and there it is. And we're done. All right, let's keep moving on. Nothing to it but to do it, right? A circle has a diameter of 0.5 feet. What is the approximate area of the circle? So if the diameter of the circle, we're dealing with flat figures now, two-dimensional figures, has a diameter of 0.5 feet, what is the radius, which is of course what we need, any radius, all radii are equal, they're all 0.25. You just divide the 0.5 by 2, and that's in feet. Our answers, a couple of our answers are in feet, so let's move on with feet and see if that gives us an answer. So pi r squared, wait, area, oh yeah, we're dealing with area. So area of a circle is pi r squared. It makes a funny, incredibly inaccurate sentence, at least it's a complete sentence, unlike circumference. And we do 0.25 feet squared times pi. You can go in any order, of course, and we get 0.19 square feet, 0.1963 square feet. That's not going to do it for us. Now, if we're really clever, we know that there's 144 square inches in 1 square foot, so we're going to just multiply that by 144, and we get 28.26 square inches. Now, the alternative to that would be just going back here to the very beginning and just relabeling it. This, instead of half a foot, how many is half a foot? That's right, Sean, half a foot is 6 inches. So the whole thing's 6 inches, so the radius would be 3 inches, and we can do it that way. 9 times pi, 28.27. I guess they use 3.14 instead of the pi on the calculator, but that's fine. Okay, moving on. A cylinder. So we're going from circles to cylinders, all right? So a cylinder is a prism of sorts. Okay, a cylinder, best name for a cylinder is just a can. Cylinder is like a can. It has a height of 6 feet and a radius of 6 inches. So there's our radius right there. What is the volume of the cylinder? Select all that applies. So this is 6 feet. I'm going to change it by multiplying by 12 to 72 inches. Okay, 72 inches. That way, this is in inches and that's in inches, and I can solve. If we go back to our, well, I'm going to have to delete that. If we go back to our reference sheet, our EOC reference sheet, which will be there, the volume of a cylinder is on there. So we know the volume of the cylinder, it's the same as a regular prism, it's just that your base happens to be a circle. So pi r squared is the area of a circle, there's your base, times the height. So the height is, in this case, 72, so we're going to plug all this in. So notice how, by the way, all the answers have pi in them. That means we're not going to multiply by pi. We're going to leave it alone and just deal with our numbers. All right, so we're just going to do 36. 36 times 72. Oh, time to switch periods, guys. Go on to your next class. Just kidding, of course. Nobody's here today. So 72, 2592 cubic inches. And we got to convert that to feet also, because we might have another answer here. Now, if we think about a cubic foot, there's a clever way to do that. If we think about a cubic foot, if that's 1 foot, that's also 12 inches. And the volume of a cube is length times width times height, or whatever orientation it is. So 1 times 1 times 1 would be 1 cubic foot, but 12 times 12 times 12 is 1,728 cubic inches. So we could just take our answer that we already have and divide it by 1728, and we get 1.5 cubic feet. The alternative to that, of course, is to leave this in feet, okay? Leave that in feet and change this to feet, all right? So that would be 0.5 feet, okay? And then run your same exact formula, same exact volume formula with feet. So easy enough to do both ways. This one's not bad at all. Area of a parallelogram is on your EOC reference sheet. Let me show it to you since I haven't started drawing yet. Parallelogram is up here at the bottom of the first page. There's your area, base times height, just like a rectangle, because it has the same area as a rectangle, relatively. It's just sort of fallen over. It's the leaning rectangle of geometry. So let's, what's the area that, so it's just 1/2 base times height. 1/2, 2.5 times 15, right? Right? Isn't that correct? You got me, Levi. You caught that. You caught that. We're not in the same units. We got to get to the same units. So let's convert this to feet. 15 inches. No, let's convert that to inches. That's a little easier. 2.5 inches times 2.5 feet times 12 inches is 30 inches. Okay, 30 inches. I can't see that 3. So 30 times 15 times 15. Now we're in inches. So 15 is 225 square inches. Okay, and it's not there. Oh, it's not 1/2? Mr. Pierce. Actually, that was a test. I was making sure that you guys saw that mistake that I made. It's not 1/2 base times height. That's triangles. It's just base times height. All right? Gotcha. So 30 times 15 is our 450 square inches. And we don't need another answer, so I think we're done with that one. Okay, let's move on. Which of the following could be the first step to correctly computing the area of the triangle? So we've got different units here once again, so we want to convert our units. So we're not going to multiply because they're not the same units. We're not going to add anything together. They're not the same units. And we don't add in triangles anyway unless we're looking for perimeter. Convert 0.6 meters to centimeters. That'll work. That way this would be in the same units as that. Or we could convert 40 to meters. No, if we converted one to the other and then the other to the one, we would end up right back where we started. So let's convert 40 centimeters to meters. Either one of those would be a good first step because we need the same units. This, again, I don't know if these units, all these strange problems with these different units are on the EOC like this, but it's still great practice and it's a great reminder how to use these formulas, okay? These formulas that for the most part, are on your EOC reference sheet this year. All right, so the diameter of a circle is 18 inches. What is the approximate area of the circle in square feet? The diameter is 18 inches. They tell you that right away. The diameter, remember, goes all the way through. I know we're just doing circles right now. So then one radius would be half that. So that would be 9. This would be 9. This would be 9. All radii are equal. We can label them all the same. They're all 9. 9 inches. What's the approximate area of the circle? So we're going to use our 9 area. They're asking area. That's pi r squared. So we're going to use our 9. 9 squared is 81. 81 times pi. Pi is not in here, so we are multiplying by pi. 3.14 times 81. We get 254 square inches, but that doesn't work for us because we've got square feet here. So we're going to divide that by 144 and get 1.77 square feet, so A, okay? We divided by 144 because there's 144 square inches in a foot, okay? Because remember, a square foot is 1 foot on a side, so 1 times 1 square foot. But if we change that to inches, a foot is 12 inches, 12 times 12 is 144. So there's 144 square inches in a foot. All right, and let's see how many we have to go. I want to make sure I get through this. 2 more to go, great. Make sure to get through this before the video is too long to upload, all right? Tristan has 4 pieces of wood. The length of the pieces are 6 inches, 4 feet, 30 inches and 3.5 feet. So we got 2 feet and 2 inches. So I don't know which way to go, so we'll just try both. So we'll do everything in inches. So we'll bring our 6 inches down. We'll bring our 4 feet down. That's 48 inches. 4 times 12. We'll bring our 30 inches down, and we'll bring our 3.5 feet. We're going to use a calculator just to avoid making a careless mistake. 3.5 times 12 is 42. We're going to add all of these up, plus 30, plus 48, plus 6, and we get 126 inches. Is that right? Yeah, 126 inches. And then to get feet, this time we're not dealing with square feet. It's not 144 or, God forbid, cubic feet. We're dealing with linear feet or lines of feet. So we're just going to divide it by 12. Divide by 12, and that would be 10.5 feet. There we go. It's B and D. One more, guys. One more, and we're going to move on to another video. The area of the triangle is 4.5 square feet. So that means, think about area of a triangle. Area of a triangle is 1/2 base times height. And remember, you're always just plugging in what you know and solving for what you don't know. That's where your algebra skills come in handy. Solving for what you don't know, getting rid of all the stuff and getting that variable by itself. So let's see what we know. We know the area, 4.5, and it's in square feet, which is a little bit annoying again. This is in inches. I'm gonna go ahead and convert that to feet. 18 inches is 1.5 feet. Now, some of our answers are in feet, so we'll just do this first. So that equals 1.5, so 1/2, I'll call that the height, and then our base would be the question mark here. So that's our base, and then our height is 1.5. So we're gonna, you can multiply that together, or you can divide by both of them. I'm gonna multiply 1.5 times 1/2, and of course that's 0.75, and then 4.5 divided by 0.75. I'm doing a lot of this sort of on the fly, okay? Because you want to move fairly quickly as long as you're thinking clearly. And the base would be 6. But what were we in? We were in feet. So 6 feet is not one of the answers. So we're going to convert it to inches. 6 times 12, 72 inches. There we go. That would be R. And let's double check that just to make sure. All right. That answer's not marked. Here we go. I'm changing the answer key right now. We solved it. It is R. So that should work. And I hope that's the right answer. I hope geometry teachers around the country aren't watching this video and going, oh, you made a lot of mistakes back there. But it happens. Teachers don't know everything. But we do try to convince you to start thinking about stuff and paying attention to the details. All right? Because that's the skill that's going to help you one day later in life. All right, let's go on to the next one. Ready?